Hi everyone, my name's Evan and I'm part of the technical team here at Zymbit. And today I'm going to be walking you through the Getting Started guide for Bootware 1.3 release. Let's talk about what Bootware is and what Bootware is not. Bootware is not a hypervisor. It's a full-featured native OS switcher and manager with support for encrypted root and data partitions. It is also not an operating system. This means you can load custom operating system images on top of it. It is also not a cloud stack. This means it should interoperate easily with most popular cloud stack applications. In this tutorial, what we'll be doing is taking a blank setup, installing our Bootware software, configuring an image, configuring the update parameters, and then actually applying that update to the same device. Now, in a real-world scenario, what you might actually have is a source device that creates images, and then a whole fleet of devices around the world that will then be updated with that image that we create with the source device. The first thing you're going to want is to get everything situated with your hardware and software. In order to do this, you'll need a Zymbit security module, whether that be a Zymt, an SCM, or an HSM. You will also need a Raspberry Pi, and you'll also be needing an operating system that we currently support with Bootware. Please look at the documentation to see which devices are supported and which operating systems are also supported. Further, you'll need to install the Zymbit drivers and security tools package on your device. This package is separate from Bootware and is required to connect to the Zymbit hardware security processor, whether that's on a Zymt, an HSM, or an SCM product. The encryption step of the driver package installation is not required for the Bootware source device. On image recipient devices, Bootware will create encrypted partitions upon image deployment, and thus an explicit encryption step is not necessary. The only time the encryption step is recommended is when the Bootware source device has to have at-rest encryption. On your fleet devices, you'll need a couple things. Number one, you'll need the hardware, so a Zymbit module like we mentioned earlier. You'll need the operating system and an image that already has Bootware software installed. And you will also need the public key to verify the downloads and the updates from the source device that are generated on the source device. With that said, let's get started. The first thing I have is my Pi running with the Zymbit hardware, with the Zymbit software installed and fully configured, so you can see the blue light blinking once every 3 seconds. That means the security module is talking to the Raspberry Pi and everything's happy on that regard. Now we're going to install the Bootware software. So if you go to our documentation site, the first step is download Bootware. Copy and paste this curl command, and if you're looking at the computer screen, what you see on the right is a terminal SSH'd into a Raspberry Pi 5 with the Zym key attached to it. So we're going to paste the curl command to download the software, and what this is going to do is actually download the binary that installs our ZB CLI, which is how you run and configure all the Bootware steps. The first thing it's going to ask you is if you want hardware signing as well as software signing. So what this means is it gives you the option to use hardware signing in later steps or just software signing. So if you select yes, it's going to give you a binary that gives you the option to do both. If you select no, you're only going to have the option to do software signing in future steps. For this tutorial, I'm only going to be using software signing, so I'm going to select no and continue on. Next, it's going to ask you to select which ZB CLI version you want. We highly recommend always using the latest version of our ZB CLI. And if you don't know, please be sure to reach out to us and we can help with any ambiguity there. So I'm going to install the latest version, 1.3. After this, it'll have all the things installed, but now we need to actually apply the installation. As you can see here, and on the Getting Started guide, you run sudo zbcli install. So this is going to tell you how much space Bootware is going to take up and then ask you to confirm. This now is going to do is tell you which files are created, which files have been installed, and which files have been modified for the actual installation of zbcli. And we need to reboot for those actually to take effect. Now is a good time when you can look at the output of the Pi 5 on the console, and you can see it rebooting, and then eventually you also see a Bootware splash screen pop up during the Bootware installation. Now that the Raspberry Pi is rebooted, SSH back into my Raspberry Pi. And now we're ready to actually make an image from our device that we'll then apply with the update. So the first thing you're going to want to do is run the ZB CLI image, which will then create the image. It'll also ask you at that time where you want to store this image. For this demo, I'm going to be using a USB stick that I have plugged into the Raspberry Pi. So now that is mounted, we can actually run the ZB CLI imager, which will then take you through a series of steps. So we'll run the imager, and it's going to ask you for the output directory. And so that'll be the USB stick that I created. All right, now I'm going to do my image name. Now it is going to ask you what type of image you want to create. The two options are a full image of this live system or an overlay image of selected files. Full images are deployed on a new, clean, encrypted file system, while the overlay images are applied over an existing installation. So you could have one source device where you create your images, and then on your fleet devices, simply accept the update with this image you created from the source. A full image will take your running system and copy it exactly and create an image based off of that. Overlay updates, you can specify select files that you want to update instead of creating an entire image. For this setup, I'm going to make a full image of the live system that's currently running on this device. You can optionally enter an image version, and now it's going to ask you what type of key or select the key you want to use to sign these images. In previous step, when I mentioned hardware signing or just software signing, we selected just the software signing option, which is why you're only seeing the option to create a new software key or use pre-existing software keys. If we installed the binary with hardware signing support, you'd also see an option to use hardware signing at this step. Now, I have not created a public-private key pair on this device yet, so I'm going to select create a new software key. So you'll see a lot of the output of all the files it's created, everything's been modified, and everything that's been saved. This also might take some time depending on how big your running system is, or it could also go a lot faster if you're only using select files in a manifest. Once the image is created, you'll end up with 3 files on your mount point: the actual ZI image file, the private key, and the public key. The .zi file contains the image proper and is not encrypted at this point. The public key must be distributed to image recipient nodes to validate the image signature. The private key should be safeguarded, and it will be used to sign all subsequent updates and should not be distributed to the target nodes. The steps we've just gone through complete the image generation process. First, we installed the Bootware software. Next, we decided what type of image we wanted to create. And then we decided where we want to store the image and its associated keys. In the second part of this video, we'll go over how to deploy and update to a target device. You can find all the links below. Thanks for watching.